Let's begin by examining sequences. Sequences will not be a major topic on your test, but there is a good chance you will get at least one sequence problem somewhere along the way. The basic concepts are not too complex. A sequence is a set of numbers generated by taking some number as your starting point and then plugging that number into a given formula to get a second number. This second number becomes the second element in the set, and so on. Creating a sequence is a cyclical process. Once we have a second number, we can generate a third, and so on and so forth. Basically, a sequence involves generating new numbers by plugging the newest number back into the formula that generated it. Let's take a closer look at a sequence formula. A sub n plus 1 equals A sub n plus 4. Now this may not appear complicated at first. In this scenario, every number in the sequence is represented by an A. What you want to do is assign a position to each number with a variable n. The first A in the sequence will have n equals 1, and therefore you'll get A sub 1. The second number in the sequence will have n equal 2, and here we'll have A sub 2. So on and so forth. For example, the 100th number in the sequence will be A sub 100. If A sub n is a given number in the sequence, then A sub n plus 1 is the next number. You'll have A sub n plus 1, A sub n plus 2, so on and so forth. Let's use what we've just learned about sequences to find the value of A sub 4 in the following example. If the formula for a sequence is A sub n plus 1 equals A sub n plus 7, and if A sub 1 is equal to 3, what is the value of A sub 4? So here we're trying to solve for the value of A sub 4, and we have the starting point, A sub 1. So we literally want to solve for every number leading up to A sub 4. So if A sub 1 is 3, A sub 2 is going to equal A sub 1 plus 7, or 3 plus 7, which is 10. Now that we have the value of A sub 2, we can solve for the value of A sub 3. A sub 3 is going to equal A sub 2 plus 7, which is 10 plus 7, 17. And now that we have the value of A sub 3, we're now ready to solve for the value of A sub 4. A sub 4 is going to equal A sub 3 plus 7, which is equal to 17 plus 7, 24. If we know the formula for a sequence as well as the position of a value within the sequence, we can also work backwards. For example, if the formula for a sequence A sub n plus 1 is equal to 2 times A sub n plus 5, and we know that A sub 5 is equal to 107, we can use this information to solve for A sub 1. So let's work backwards. In this scenario, let's make A sub 5 equal A sub n plus 1 for our formula. A sub 5 is going to equal 2 times A sub 4 plus 5. So we know that A sub 5 equals 107. Now that we have this number, let's plug it back into our original equation. We know that 107 is going to equal 2 times the number before A sub 5, which is A sub 4, plus 5. So you subtract 5 from both sides. You get 102 is equal to 2 times A sub 4, so A sub 4 is equal to 51. So A sub 4 is equal to 2 times A sub 3 plus 5. Well, A sub 4 is 51, so 51 is equal to 2 times A sub 3 plus 5. Now when we solve for A sub 3, we subtract 5 from both sides. We get that 46 is equal to 2 times A sub 3. So a sub 3 is equal to 23. So now we're going to plug it back in and do the exact same thing. We have that 23 is equal to 2 times a sub 2 plus 5. When we solve for a sub 2, we get that 2a sub 2 is equal to 23 minus 5, 18, and we get that a sub 2 is equal to 9. Last one, we know that 9 is equal to 2a sub 1 plus 5. So we subtract 5 from both sides, and we get 2 times a sub 1 is equal to 4. So a sub 1 must equal 2. Excellent. Remember, a sequence is just a series of mechanical calculations. If you know the formula for a sequence and the value of at least one position in the sequence, you can find all other positions by calculating backwards or forwards.